Welcome back. In this problem, we have multiple forces. There's a whole bunch, as a matter of fact. I'll show you how to label that. And it's hooked up to a spring. What I want you to do is see two different things. One, that's how we draw it symbolically. So whenever I say there's a mass on a ramp and it's hooked up to a spring, this is what it would actually look like. So in this problem, we have a mass hooked up to a spring and it's tipped. Well, in reality, that'll oscillate back and forth a couple of times, but in this problem, it wants to know when it comes to rest, how far is the spring stretched? Okay, so that's what we're going to find. If I tip it more, it stretches more. If I had more mass on that cart, it would go a whole lot farther. So in this problem, there's a 44 kilogram mass attached to a ramp that's tipped 23 degrees, and the spring constant is 111 newtons per meter. This is another excellent way for us to test the guess method. Now, in these force problems, there's sort of an intermediary step right there when you're in the solve part. I need to draw a diagram and label all the forces, because force is a vector, and we can't add x stuff and y stuff. So, first, what's given? Well, I listed the given up here for you already. We can cross that off our list. Unknown, we know that. We're trying to find out how far did the spring stretch. Cross that off our list. And then equation. Well, before I know what equation to use, I need to draw and label all the forces. So I would draw it like this. Just a simplified version of the diagram. There's my ramp. There's the block. The first force I would label would be the weight. And the normal force. Well, if you saw the previous video on Fagramp, we know that weight and normal force add up to Fagramp. If you haven't seen that video, I'd suggest you go back and watch it. It's a cool shortcut. This is the vector sum of the weight and the normal force. It's sine theta of the weight. And there's one more force that I haven't drawn in here, and it's the spring force. All right, now the reason I have to do that is this question asks me, when it's in equilibrium, once all the forces are balanced, how far is the spring stretched? Well, now that I look at this diagram, I can think, okay, well, when the spring force is equal to Fagramp, that's what's going to keep it at a point where it's not accelerating anymore. So that's my equation. The spring force is equal to Fagramp. So in this problem, I know what equation I'm going to use now. I'll go on to the solution. Okay, now what I did here is I wrote out the equations that were equal. The spring force was equal to Fagramp, plugged in my formula for spring force, plugged in all the givens that I knew, typed it into my calculator, double check and make sure your calculator is in degrees. If it's in radians, you'll get the wrong answer. And hit enter, and I found out that the spring would stretch 1.55 meters. There you go. That's how you use the guess method to solve problems in force. See you in the next video.